Hey guys, welcome to the help video for quiz 6.02. Alright, so in this video we are going to be graphing dilations. And so first we just need to think back all the way to Unit 1 and remember what a dilation is. A dilation is when you multiply by a scale factor to make an image bigger or smaller. Now remember, if you multiply by the absolute value greater than 1, like if you multiply by 2 or -2, you're making it bigger. If you multiply by a scale factor with an absolute value less than 1, like 1/2 or 0.33 or -2/3, anything that's the absolute value is less than 1, you're making it smaller. So we're going to talk about how to graph them today. The first thing you want to do is mark the center of dilation on your paper. I usually mark it with a star. Then you're going to find the distance from the center of dilation to your first vertex. Make sure you follow the grid. Don't just kind of draw your own diagonal line. You have to follow the grid to get there. And once you find that distance, you're going to multiply the distance by the scale factor. Then you're going to plot your new point from the center of dilation, and then you're going to repeat those steps. So I'm going to walk you through that. I'm going to show you a couple of examples because I know they sound kind of confusing. I also put up here that there is a shortcut. If and only if the center of dilation is at the origin, then you can just multiply the ordered pairs by the scale factor. So I'm going to start showing you all of that. Okay, so here is our first example. We're given a triangle, and we want to graph the image of the triangle after a dilation of a scale factor of 2 and a center of dilation at the origin. All right, so since our scale factor is 2, our triangle should end up being 2 times bigger. So if you end up with a triangle that's smaller, you know you've done something wrong. Okay, so the first thing I'm going to do is I'm going to show you the full method for doing it, and then I'll show you the shortcut. So to start off with, I like to graph my center of dilation. Okay, now what I'm going to do is I am going to pick a vertex, doesn't matter which one, I'm going to go to the blue one. And from my center, I'm going to count how I got there. So it looks like I went up 1, 2, 3, 4. And backwards 1, 2, 3, 4. So over on scratch paper, I'm just going to make myself a note that I went up 4 and backwards 4. And now I'm going to take that distance and I'm going to multiply it by my scale factor, which is 2. So I'm going to multiply the top and the bottom by 2. And that tells me that to get to that new ordered pair, I need to start at the center and go up 8. And backwards 8. I want to go twice as far from the center to my new point. So I'm going back to the center, I'm counting up 8 and backwards 8, and that will be my new blue vertex. Okay, let's look at that again. Let's use this red vertex now. I'm going to start off at the center, and I'm going to count the distance following the grid how I got to that point. So I went down 2 units, and then backwards 4 units. So I'm just going to make myself a little note. This is just scratch work that I went down 2 and backwards 4. And then I'm going to multiply that by my scale factor. I want to change that distance. I want to make it 2 times further. So my new red vertex would be down 4 and backwards 8 from the center. So I'm going to always go back to the center of dilation. So from the center of dilation, I'm going to go down 4 and back 8 units. And then my third vertex happens to be at 0, 0, and that is the center of dilation, and so it's going to stay at the center of dilation. So this would be my new triangle that's twice as big as my original with the center at the origin. Okay, I also want to show you the shortcut, because if the center is at the origin, you have a super awesome shortcut. All you have to do for the shortcut is write down your ordered pairs. So -4, -2, and then multiply that ordered pair by the scale factor. So multiply each of those pieces by the scale factor, and that tells me that my new ordered pair should be at -8, -4. And if we look here, it was at -8, -4. So that's a shortcut you can take if and only if the center is at 0, 0. So I could have taken this ordered pair, -4, 4. I could have multiplied it by the scale factor, So multiply each of those by 2. And my new ordered pair should be located at -8, 8, which it is. And then you would have taken your last one, which was at 0, 0, multiplied it by the scale factor, and you would still end up at 0, 0. So the shortcut if the center of dilation is at the origin is you can just take your ordered pairs and multiply them by the scale factor. Let's look at another one. I tend to not use the shortcut, but by all means you can. So I think we have 2 more. Let me make sure we have 2 more of these. Yeah. Okay, we have 2 more that are centered at the origin. So I'm going to do one using the distance, and I'm going to do one using the shortcut. Okay, so the first thing I'm going to do is I'm going to graph my center of dilation. It says that I'm going to have a scale factor of 3 centered at the origin. So I'm going to put a point or a star or something to remind me that's the center of dilation. And then I'm going to pick a point. I'm going to pick this ordered pair. And I'm going to start from my center and follow the grid to get there. So I'm going to go up 1 and over 1 to get to that blue vertex. And I want to make that distance 3 times further. So I'm going to multiply the top and the bottom by 3. So my new distance from the center, it always goes back to the center, is I'm going to go up 3 and over 3. And then I got to do those same steps with the next vertex. So I'm going to pick this vertex next. From the center, I go up 1 and backwards 2. So I'm just going to make myself a little note on scratch paper. And then I'm going to multiply that distance by 3, which is my scale factor. I want to make that distance 3 times further. So now I'm going to start back at the center. You always start from the center. You're going to go up 3 units and backwards 6 units. And then we pick another vertex and we keep going with those same steps. So I'm going to start at the center and I'm going to mark how I get to that point. I go down 2 and backwards 2. Now again, this is just scratch work. Then you multiply those distances by the scale factor. And so now I need to go back to the center and travel down 6 units and backwards 6 units. And then we're going to pick our last ordered pair and finish it up. From the center of dilation, I go down 2 and over 1. So I multiply that by the scale factor to figure out my new distance. So from the center, I would go down 6 and over 3. And then I would draw my new figure. And that makes it 3 times bigger, centered at the origin. On this one, I'm going to go ahead and show you the shortcut. I want you to be okay with both methods. So this says graph the image after a dilation with a scale factor of 1/2, centered at the origin. So because it's centered at the origin, anytime you see centered at the origin, you can take your shortcut. And in order to take the shortcut, you just need to write down each of your ordered pairs. So this one is at -4, 2. This one is at -2, 8. And this one is at 2, 4. Once you have those 3 ordered pairs, you're going to multiply each of those values by the scale factor. So I'm going to multiply each of these times 1/2. Now don't divide by 1/2. When you do scale factor, you are always multiplying. It confuses some people because multiplying by 1/2 is the same as dividing by 2. If you know that, then you can do that, but otherwise just try to keep in your brain that scale factor is always multiplying. So let's multiply each of these ordered pairs. Here, half of -4 is -2, half of 2 is 1. So my new point would be at -2, 1. Up here, half of -2 is 1. Half of 8 is 4. So it would be at -1, 4. And then over here, half of 2 is 1. Half of 4 is 2. So this would be my new triangle that's half the size, centered at the origin. Okay, the next one says, graph the image of this figure after a dilation with a scale factor of 2, so we're making it twice as big, centered at 2, 2. You cannot take the shortcut unless it's centered at 0, 0. So for this one, we have to use our 3 or 4, however many steps. So the first thing we do is we plot the center of dilation. Okay? And then like we did on the first couple, we're going to pick any vertex. And we're going to start from the center and just count the distance of how we got there. In this case, we go up 2. And I'm going to multiply that by my scale factor. So to get my new point, I would want to start at the center and go up 4. And then we pick another point. Let's pick this purple one. And we do the same thing again. So we find the distance from the center. We went up 1, 2, 3, 4, and backwards 2. So I went up 4, backwards 2. Multiply that by your scale factor. So that tells me from the center to get to my new vertex, I want to go up 8 and backwards 4. And then we do it for our last vertex. Once you get the hang of this, it gets pretty easy. It's repetitive, but it's easy. So from the center, you're going to go up 1 and backwards 5. Multiply that distance by your scale factor so that you go twice as far. And then back at the center, you want to go up 2 and backwards 10. And then you can draw your new triangle. That triangle is 2 times bigger, centered at 2, 2. All right. This one says, graph the image of the figure after a dilation with a scale factor of 1/3, centered at 4, -2. So our triangle is going to end up being smaller. It's going to be 1/3 of its original size. The first thing we always do is plot our center. So at 4, -2, that's going to be my center of dilation. And then I'm just going to pick a vertex. And from the center, I'm going to count how I got there, following the grid. So I go up 1, 2, I'll draw it. 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So I travel 6 over 3 to get to that vertex. I want to multiply each of those by 1/3. So my new distance would be 2 over 1. So from the center, I'm going to go up 2 and over 1. That would be my new vertex. And then pick another color, or you don't have to color code, I always color code. Pick another vertex, and then from the center of the dilation, count to see how you get there. So here we go up, let's see, 12 and backwards 3. Multiply each of those by 1/3 to get the new distance. So I would go up 4 and backwards 1. And if you're uncomfortable doing 12 times 1/3, type it in your calculator. That's not something that you have to stress about. And then pick your last vertex, start from the center, count how you get there. So I go up 6 and then backwards 6. Multiply it by your scale factor. So my new distance would be up 2 and backwards 2. And then once you have your 3 new vertices, you can just draw it. And that's 1/3 of its size, centered at 4, -2. Now I do want to mention, since I have just a tiny bit of time left, if you connect the corresponding vertices, they should always go through the center of dilation. So if I connect blue to blue, it goes through the center. If I connect red to red, it goes through the center. And if I connect purple to purple, it goes through the center. That's a way to double check to make sure you've done it correctly. So let's go back and double check this. Connect purple to purple, connect blue to blue, and connect red to red. And notice all 3 of those intersect at the center of dilation. You could do the same thing for all of them. So this is just a really great way for you to check your work. And they all intersect right there, which was at the origin. So that's great. And then lastly, connect blue to blue, green to green, red to red. Oops, that was terrible. Anyways, y'all get the idea. Good luck on your quiz.